Hi guys, welcome you all to my channel Explore Edu to Teach.
Okay, so the next topic that we are going to learn today is the properties of Z transform. There has been already a video which has been uploaded on Z transform basics and the ROC. So if you haven't watched the video, it is there in the I button over here as well as in the signal and system playlist of my channel. So please go and watch it out. That will give you a basic understanding about Z transform, how to deal with Z transform and so on and so forth. Once those concepts are clear to you, then today we'll be understanding about properties of Z transform and also about a numerical on Z transform. So I hope I'm very clear with this. So let's start away with the properties of Z transform. So what does the property of Z transform say? X of n is basically a discrete signal, whereas x of t is a continuous time signal. So x of n produces x of z. So x of n minus m is equal to x of z into z raised to minus m. If x of n corresponds to x of z, n into x of n is equal to minus of z raised to n d by dz of x of z. Similarly, if x of n corresponds to x of z, x of minus n corresponds to x of z inverse. Y of n corresponds to x1 of n convolution of x2 of n. Therefore, y of z, which is a z transform of y of n, is corresponding to x1 of z into x2 of z. Next, we have the initial value theorem. Initial value theorem says that the x of 0 is equal to limit of z tends to infinity x of z, and x of infinity is equal to limit of z tends to 1 minus z inverse into x of z. So I hope I am very clear with you what are the properties of Z transform. The properties are given over here. The notes are there in the description box as well. Please download it from there. Now we'll be solving one particular numerical which is mostly asked in university exams also, and to certain extent in the competitive exam like GATE. So let's try to understand how to find out the inverse Z transform of a given Z transform. So how are you going to get finally x of n if x of z is mentioned to you? So if you look over here, x of z is given as z upon 2z square minus 3z plus 1. That is equal to z upon z minus 1 into 2z minus 1. Now what you need to do is that 2 you need to take out from here. And what remains is z minus half. So basically I have x of z which is given as z upon 2z square minus 3z plus 1. Just factorize it to find z upon z minus 1 into 2z minus 1 is equal to z upon 2 into z minus 1 into z minus half. So this is the z transform which is given to me. I need to reduce it and find out the x of n from it. That is the discrete signal, the inverse Z transform. So what we are going to do is, the x of z is given to us. Fine. We are going to add z in the denominator just for the calculation purpose right now, and then we'll be eliminating that. I hope I'm very clear. The x of z is given to you. From this x of z, find z upon z minus 1 into 2z minus 1. That is equal to z upon z minus 1, and 2z minus 1 can be written as 2 comes out and z minus half. Now this value we are adding z in the denominator for some calculation purpose which you will be understanding now. Then we can eliminate that z. So what we are doing is that in this equation we are just adding a z in the denominator and we are doing the partial fraction method. So what is the partial fraction method? Half we are taking common, a upon z, that is every term of the denominator, plus b upon z minus 1 plus c upon z minus half. Okay, then what happens is that we are going to find out z value over here, and a is going to be z minus 1, z minus half, b will have z into z minus half, c will have z into z minus 1. all these things, and the denominator will straight away get cancelled. Then we have a value, and then we have over here, if you see, the a value, b value and c value. So just solve it, compare it with z, and you will get the values as a is equal to 0, b is equal to 2, and c is equal to -2. So just put these values in the equation number 1. Understood? Now what you have to do is that, hence you will get half into 0, because a is 0, plus 2 into z minus 1 minus of 2 into z minus half. Now understand that, as I told you, that this z that we had added in denominator was a extra z just for calculation purpose. So I'll just bring this z on the right hand side. I'll eliminate this z by multiplying z on both the sides. Fine. So what happens, z gets eliminated from here, and we'll have z on the right hand side of the given equation. So if you see, you have half into 2z upon z minus half, z minus 1, minus 2z into z minus half. So you have half over here, 2 value, z upon z minus 1. Z upon z minus 1 is given as a raised to n u of n, and over here minus 2 into z minus half is given as half raised to n u of n. So that is given as mod z greater than 1. Similarly, if the ROC has to be smaller than 0.5, we will take it as in non-causal format. Because if you see, when mod z is greater than mod a, we have a raised to n u of n for z upon z minus a. However, if my mod z is smaller than mod a, it is given as minus of a raised to n u of minus n minus 1. So I hope I am very clear to you. In such a way, we can have a causal signal where mod z is greater than 1, and we can have a non-causal signal where mod z is smaller than 0.5. So that is very important. So I'll just give you an overview about things. So the overview about things says that we have properties of Z transform, which is given as over here. Next, we have taken a numerical, which is very important, in which a Z transform is given to you. We are going to convert this Z transform into the discrete signal x of n. So what we are going to have is, we are going to have the factorization of 2z square minus 3z plus 1 as this. Then we are just taking the 2 outside and getting it in this term. Now just for calculation purpose, we are trying to add a z in the denominator and then get the factorization of it. And then we get a value, b value, c value as this. Now multiply z on both the sides and you will get this final equation over here. And if you see, this was my x of z which was mentioned over here. Right? So just get this x of z to x of n which is given over here. Fine. So I hope I am very clear. I have uploaded these notes in the description box of the YouTube of this video also. So please go and download it from there. If you like the video, do not forget to like, share, subscribe to my YouTube channel. Follow me on Instagram for regular updates of all the videos and for all the shortcut tricks and everything. All the formula sheets which I will be uploading on my Instagram page also. So please do follow me on Instagram and subscribe to my YouTube channel. Share it to as many people as you can. Thank you so much guys. God bless you.